this is a lightning talk about testing and the most recent learnings in the Azure operator. It's kind of, in a way, blurry whether it's integration testing or unit testing, but I'll get back to that in a bit, but hence the brackets. Because it's quite blurry, I'm defining like what do I mean by unit testing and integration testing in this presentation. Like in the wider context, it might be debatable, like what does each and other term mean, but this is the thing here. So with the unit testing, I think that it's basically testing a very small unit or block of code. And in our operators, most of the time, I just consider testing of single function kind of a unit test. Because the handlers that we build, unless they are the simplest ones that only update maybe one ID in the CR status or something similar, they are quite complex and they involve many subcomponents or services. So that's why I kind of make the distinction. So when I talk about integration testing here, it might mean testing one or more handlers as a whole. And most of the time, in a way that we test the handler in isolation with the mocked external services. And then the thing, like how I see it, it's then the end-to-end tests when we are testing the full-blown operator against the real APIs. So this is slightly different than what we have been discussing some elsewhere, but this is basically the definition and distinction in this presentation. So what do we need to mock the services? We need interfaces because this is the simplest way in Go effectively to separate the different implementations from the calling side and being able to simply just configure them on the fly when wiring the components up. Theoretically, you could build some neat aggregation via function interfaces as well, but it's not that straightforward. And my experience so far has been that just using a plain interface, it makes things a lot easier and simpler. Another thing is basically that instead of using the typed clients that we used to use, which were generated with the client Go tools and where the code resides in the API extensions, the recent usage of the controller runtime client, which is non-typed, it helps a lot because the single client instance can be used to deal with different types of Kubernetes objects. And this helps in integration tests a lot because you can have the single coherent world view while you still fake the actual case API there. If we were using type-specific clients, each instance would have a different worldview, and writing the tests would be almost impossible, at least very difficult and verbose. So when building any new code using the controller runtime client is kind of the best thing that we can do. And the third thing is basically GoMock. This is a library I started testing when writing the worker migration handler in Azure Operator. It basically provides a code generator that generates a mock implementation of any Go interface. And it also provides the functionality to control the behavior of the mock service and to verify the intrinsics while the test is being run. Then testing relatively complex handler. My example here is basically the latest one, the worker migration handler. And here are more or less the steps that are required to write the test. So, or kind of like what happens in the test when you write it. So in the beginning, you set up the mock controller, you set up the K8s fake client, then you instantiate the Go mock services, instantiate the actual tested handler. You might and often do prepare the environment. This means that you somehow load the custom resource objects into the faked K8s API. Then one way or another, you prepare the actual object that will be reconciled, which is basically given as a parameter to ensure created, for example. You configure the behavior and the intrinsics of the Go mocked services. This basically means that when there is a mocked service interface, you define that when any given function from the interface is called, there is the pattern matching for the parameters, and there is also the potential return value that the service interface call should return. And then as a last step, you can define the number of times that the function may be called. So this can be also used for verification. And then everything is set up, so you can just call the ensure created and execute the handler. And if necessary, you can verify the faked K8s environment afterwards. Here is basically a small snapshot of a test, which runs to the point of executing the handler. So there is the setup of the mock controller. There is the setup of the fake client, instantiation of the resource or handler, loading of the CRs, and then configuring the mock service. I will share the slides also afterwards in case someone wants to look more detailed here. So that's how the step, or that's how the tests are kind of set up and written. Then another thing kind of related to this is the TDD. I kind of had the idea that I try to write the tests first, because I was able to mock all the dependent services. So I just wanted to write like case-by-case tests and then implement the migration handler. But it turned out in the end, like often before in my past as well. So it's not really a silver bullet. You end up thinking kind of from small steps at a time. You write the test, the minimal requirement for that. Then you write the minimal required code for that. You write another test and you repeat. And the outcome may not be really that perfect in reality. I personally think that it was not a good approach in this case. It took more time than just directly writing the actual handler. And it also made me do silly things in the actual implementation, such as, did you know that you can pretty much destroy the cluster if you just call on all the nodes, including the master, and then you just roll out everything? The master cannot start because it's caught, and so it's fucked. Another case of testing, or kind of another case of integration testing, so to say, is testing multiple handlers together. And this is also related to node pools implementation, where we needed several handlers that perform CR mapping from our legacy types to CAPI and CAPC types, but also the other direction from CAPI and CAPC types to legacy types. This was necessary because the control plane of the node pool cluster is still reconciled by the Azure config. And on the other hand, when upgrading old cluster to node pools, we needed to have both CRs there. So there are several handlers which implement this. And in order to keep them synchronized together, the most convenient way to kind of verify this is to set up some set of CR objects on faked case API, and then execute both handlers and verify the state afterwards. And that way you can first control the start state by having several different CRs and just loading them in different test cases. And then by running the handlers in different orders and then just verifying afterwards, like what was the outcome. And here is effectively the kind of thing that happens when executing through the test, but also during the runtime. One negative side here is the YAML, especially the Kate's use of the YAML, because they don't natively use the YAML as kind of data language, but instead they read the YAML, they translate it, or as I said here, kind of transliterate, which is more precise, to JSON, and then that JSON is passed into Ghost structs. So depending on the YAML implementation, you might end up with completely wrong outcome, which is compiling perfectly. It respects all the API contracts, but the logic that kind of comes out from there, it's wrong. And when writing these tests, like you might in the beginning see that everything seems fine, everything works. Then you are executing stuff in the real life cluster. And at some point you start to see really, really weird situations. And at that point you realize that, okay, this was not right. And when looking more carefully, very detailed fields of the YAMLs used in the tests, they are actually wrong. And there is only like 1 or 2 cases where you can use specific YAML library which works correctly. And that's quite nasty. So this was kind of negative side of like testing without the real environment. But yeah. So kind of in the end, the good side, it's basically that when using the mocked services and the mocked implementation of interfaces, they pretty much give you full power of reproducing logical bugs in a concise way, so that you can also get a fast feedback loop and that way fix bugs. And for me, this feels like the best use case of the whole technology stack. Together with this, it's also something that you are able to write tests that extensively kind of go through many interfaces, and that way they overall build kind of the contract, how the whole component should behave. And when you have more and more of these kind of tests, it gives you more confidence when changing the implementation or refactoring the whole source code or the code base, but also when updating individual libraries. And kind of as a last thing, especially related to CR mapping, but also used partially in the worker migration tests, is that using initial state CR files, or sorry, YAML files that you load during the test execution, but also using the golden files approach when verifying the test outcome, that makes it very easy to multiply the test cases and create minor variants there, but also it makes it easy to update the verification state that you expect to happen after the logic is executed. Because in the past, especially in the beginning when I started at Transform, I wrote quite a lot of unit tests using the fake case client, but writing the verification code as code. And when changing the function implementation, it's really annoying to kind of come back half a year later, 1 year later, try to understand the tests, and then updating the behavior or expectations of the tests in comparison to modified function implementation. But with the golden file verification, you can just have the update flag, which basically updates all the files. And that way, the expected situation or expected state is easy to update, but it stays static until you really need to change it. And yeah, the bad thing, which was mostly already explained, is that the TDD in our setting, from my personal opinion, doesn't really help with the API design. The nature of the logic that we write, that we kind of just configure some kind of external interface one way or another to the desired state, it doesn't really help the API design, but rather it might make the expectations too simplistic or kind of the filters too silly. And that will not lead to kind of good outcome. And it takes a lot more time than writing the actual implementation and verifying it. So yeah, I don't really think it's necessarily a good tool, at least for me. And yeah, the other thing which I just mentioned is basically hard coding the test verification instead of having the golden files. That kind of feels like a burden in the long run, but yeah, you might have different opinions on that. So comments, questions, or any other kind of discussion?
I just wrote an example of what you mentioned about hard coding the test outcome. So we are using it's our library, transform/something, and basically every end-to-end tests. I don't know if Jose maybe fixed this or changed something, but basically every test expects exactly 3 nodes to be spun up. So no matter what you do, it's going to expect like 1 master and 2 worker nodes. So it's a little bit tricky to test multiple node pools, since you can only spin like 2 with 1 node each. And it's an example of where hard coding test outcome is not a good idea.
Yeah.
The same was, but it was local to Azure operator, the multi-AZ test, where specific AZ and specific number of AZs was expected in the outcome. And on the other side, there is an option for the test to specify how many AZs do you want. So you can specify that you want 3 or 1, but the test always expects exactly 2, for example. So you have the option to give the input, but you're going to fail the test if you do it. I mean, I fixed that maybe, I don't know, a month or 2 ago, but yeah, it was a funny one.
Yeah, and in the past, like we used to have stuff like the version bundle library, where we tried to strictly restrict the rules of how you can actually create releases or how you can generate the releases, what a given version bundle can or must have, and so on. And the more we gained experience and the more we started to have version bundles and releases, the more we learned that we need to kind of relax or change the expectations. And every time when you go and do a change, you had to go through a lot of different tests. And yeah, having something like golden files kind of approach there, I feel like it's so much more practical, while it still gives you the same outcome. You can still guard against like unintended changes in the functionality, and you can guard against effectively bugs. So it verifies the logic, but updating the expectation is a lot easier.
And what would you think about using the golden files for the verification, but writing the input CRs as Go structs instead of loading YAMLs from file? You know what I mean?
Yeah.
Because that way you have types and you avoid the translation.
It could work. In the beginning, I would say that it's probably quite a burden. What I usually do is that I spin out live cluster. I just capture the CR, and then I just take out like the metadata fields that are not supposed to be there. And if there is anything kind of confidential, then I just mask it somehow. But otherwise, it's very straightforward to just take the data in and using it. I think the bigger problem is kind of in the output, I would say. Well, it's both ways actually. But yeah, depending on case, like you might also hit the output problem. But I would say like if we write the input data as Go structs, the tests would probably still look like that you have separate files for different test scenarios with the Go structs inside them, just like we now have the YAML files, because the structs are quite huge. So it would be difficult to maintain like the structs for many different test cases in the same file. I don't know.
This works for when the outcome has to do with the Kubernetes objects, but most of the times we expect changes on Azure, on the Azure API, right? So in those cases, that's when we want the Azure API as an interface so we can mock it and drive the execution. One question I have with this, or yeah, I don't know how to do it properly, is that if a handler needs to use the Azure API, then this interface should be defined in the handler itself. Probably. But this approach would then collide somehow or be against the direction that we are going with the Azure Factory and the Azure client set, where you instantiate the different clients, and the client that you get, the interface for the client is defined elsewhere. I don't know if I'm explaining myself. Is it clear?
First of all, I would say that if we kind of like this approach, I think we should probably like just put the Azure interface into package so that we make it kind of operator global library, because the design itself gives us a lot other benefits as well. We can control basically the implementation towards Azure a lot better that way if we use the same interface in all of the code.
Yeah, so different handlers wouldn't define different interfaces. They would all use this interface, this shared.
Yeah.
Okay.
Yeah, which would then probably grow over time the more we need the behavior from the Azure API. But that way we kind of get more or less unified, unified interface, which doesn't care about which Azure SDK API version we are using. So for example, we can update the Azure SDK APIs a lot easier than right now. And what comes to Client Factory, we probably need to think about it, but for me, it feels like we should have those two things kind of as a separate object. But it might be a question like, how do we want to implement then the mocked behavior? And how do we kind of put them together? In my approach, I took the case that, let me think about it. Yeah, I mean, it doesn't even know about that. The actual implementation does use the factory behind the API. So when you construct the handler, I gave the necessary information, basically the client factory, and possibly the secrets. I'm not fully sure. No, they are actually during the runtime. So when you call the Azure API, in the implementation, it then calls the client factory in the real code. But in the tests, all that is kind of omitted. It's not used at all. It's just expecting the result from the API.
Yeah, but you could do that because the API was defined inside the handler that you were testing.
But why can't you do that the same way with the operator global implementation?
Yeah, I guess so. I'm not sure if different clients share the same interface. I'm not sure if they all have list complete, get, or whatever. We can come up with a shared interface. I'm not sure.
No, but I mean, that's what I meant. Like we need to kind of extend the interface all the time. And I'm pretty sure that at some point we will also probably hit the point that we might want to split it into sub-interfaces.
Okay.
But that's kind of maybe long-term software maintenance thing, more or less.
Yeah, I now understand what you mean. Okay, I get it.
Maybe I got it wrong because also I'm not so familiar to Go programming, but couldn't you just mock the whole factory? Like if there's a factory for Azure clients, can this not be the interface that is mocked? Because from that on, you're completely free to have some mocking clients there.
You can mock the factory, but you don't need to implement the Azure API in the way that it depends on the factory.
Yeah.
So you could avoid the mocking altogether.
Yeah, you wouldn't need to create like a chain of mocks, making the factory returning yet another mock and so on.
Yeah.
And then just on the Azure API interface, will hide all those details.
Yeah.
Okay.
My Wi-Fi was breaking so much I will have to watch the recording for all this entire part, and then I will just ping you in Slack.
Okay.
And Thomas, so you think this interface will have functions like get PMSs or list storage accounts? Or?
Yeah, that's what I did so far. I mean, I would think that time will probably tell if we want to change that. I mean, if we start to have like over 100 functions there, then it sounds like we are doing something wrong. But in the very beginning, I would kind of expect that we end up with, I don't know, 5 to 10 Azure services, and most of the time we have kind of list, get, delete, create or update.
So if I got from the part of connection I had, are you talking about having a unified Azure interface, API, whatever? So there is a single type with all Azure functionality, and every handler would get that type.
Yeah.
Yeah, that's basically similar to, like, scope-wise, similar to what we have now. So every handler gets a factory, and then it can get whatever it wants from the factory. Yeah, before when I was thinking about it, my thoughts were going in the opposite direction, towards actually making handlers use only parts of Azure they actually use. So I don't know, VNet handler would get only VNet, call it whatever you want, VNet client, VNet API, VNet service, VNet blah blah, giant swarm, whatever. But just to scope it down to what it needs to reconcile, so it's more kind of visible when that changes. That was my thinking. I was thinking if this is maybe like similar to service locator anti-pattern, where like something gets access to everything without actually needing that. Just thinking out loud, not sure.
Yeah, and I mean, I'm not really against that. That's kind of like what I would expect maybe to happen at the point when there are too many functions in that single interface. My approach so far was like that, having a single interface, just because so far I have 3 functions there. So it didn't make sense to build the full-blown system there.
Yeah,
but
sure.
I mean, if we want to refactor everything to use that, like, sure, it's a discussion that we need to do. And it might very well make sense to actually divide it into sub-interfaces.
Yeah, maybe
it does.
Yeah,
the thing is that it does have a cost, in the sense that then the mocking becomes quite a bit more verbose when you need to have several different services mocked. But then again, it could very well be that we come with some kind of solution that we can still simplify it.
Maybe going the Azure native way, so to speak. So we have one API/service per Azure provider. So we wouldn't have like VNet separate, but we would have like network service. So we have like VNet, subnet, NICs, and gateways, and whatever goes under networking, we have it all in the same place. So, and then we would have compute, which encapsulates like VM, VMSS, and stuff like that. Yeah.
One thing that we can also do is, if you know the Go reader and writer interfaces, so you have like the individual operations that the implementation might have, and they each have their separate interfaces. And then there is the aggregated one. So we can have like one big interface with all the functions, and we can then have the sub interfaces for each and every one. So the handler implementations can have like just the VMSS interface with list VMSS, get VMSS, delete VMSS, and nothing else. And then we have the big interface, which aggregates the sub interfaces there.
And then we have a single implementation.
Yeah.
Yeah, so I like that. It's basically from the point of view of one handler, it gets like a limited access.
Yeah.
Yeah. And implementing everything in a single type is just kind of implementation detail.
Yeah.
I have a question regarding the golden files. So from my experience, mocking was extremely useful in unit tests where you just wanted to focus on your unit and the input and the output. For example, I wanted to verify that I call list storage accounts one time, and then maybe I want to update do a call to update storage accounts one time, and this is the things I want to verify. But I don't want to verify at all if Azure API or Kubernetes in the background works. I just want to see if my unit does the right calls to the right interfaces.
Yep.
Yeah. So, but because then I wouldn't need to kind of render any golden files, although because I don't want to test if Kubernetes just does its job. Am I wrong there, or like maybe I got the concept wrong?
You are right, but it depends on the use case. I mean, we might very well have tests where we are only interested in whether some Azure API gets called. Let's say in the worker migration, everything else is done. I mean, there is literally a test case. Everything else is done, the nodes are drained, and only the VMSs is left. So the only thing I'm interested in is that the Azure gets called with the delete VMSs, and that's fine. But there are also other situations where both things happen. So if we are in the middle of the migration, there is still the built-in VMSs in Azure. We already do have the machine pool object for the new node pool, but we haven't trained the nodes. So at that point, I'm actually interested in whether the drainer configs get created and how do they look like. So it depends. At one point, like we might want to test that filling of the provider IDs in the CRs works as expected. So at that point, we would mock the Azure call, which gets, say, VMSs. And in the end, we want to verify that the Azure machine pool got the VMSs ID in any given field when the test has been executed.
Yeah. Yeah, but then we could, but would we do this by kind of writing comparing it against the golden file, or by just checking a field on the CR?
It depends. I mean, if you implement it in a way that you only need to mock the API call, then it's more straightforward to compare the CR field. But if you have already the kind of the whole unit, not unit, but I mean the whole component, whether it's handler or something, if it's already implemented in a way that you always have a set of CRs that you load into the faked K8s API in the beginning, then it's possibly easier to write the test in a way that it then also compares the K8s API state afterwards to these golden files instead of looking for a specific CR for specific field. Because that way all the tests then look the same. Otherwise you start to write different tests in very different way. And when you go and you change the behavior, then you need to read carefully through every code instead of maybe updating the expectation and looking at the diff.
Yeah,
but it depends.
I was just worrying if that I, for example, I update this VMSS ID and want to have it in the thing golden file, but I maybe introduced I don't know a side effect that changes something else, and then when I finish my implementation, I would just see the tests don't match because the golden files don't match, and if I don't really look at the diff, I might just regenerate the golden files because I think it's okay, and have like something sneaking in there.
So it's then the peer reviewer who kind of fails if he lets go the whole change in the golden file instead of single field.
Yeah. Okay. Good. Yeah. I mean, maybe it's a little bit make it up because, but I had the experience in the past that if you have really complex files to compare, people would just regenerate them and don't think too much about it. But if we have the review process, maybe it's not an issue. Yeah.
You are right, and I think like it depends on case, but there are a lot of different variables that kind of affect like what makes sense in the end. Yeah. But in general state, kind of like if the test is about somehow modifying the existing state, especially in the CRs, I feel like the best way to actually do the verification is to have the golden files, because that makes the maintenance the easier. But granted, like when you update them, the whole file shouldn't change. Just individual fields in the expected ways. Anything else?
Not for me.
Okay.
Thank you very much, Thomas, for putting this together.
Yeah.
Thank you.
Yeah, this was amazing. Thanks.